This chapter on substitution reactions is a big one, so I have split it into many little parts. Okay, so the first one we are going to do is just alkyl halides and just the nomenclature, as you can see over here. Okay, so small pieces. So alkyl halides with the nomenclature. So first of all, let me clarify what alkyl halides are. Remember alkyl groups, which are the alkanes minus one hydrogen, right? So that's the alkyl group. And then when they are bonded with a halide, with anything on group number 7, that's going to be an alkyl halide. The IUPAC nomenclature would be haloalkanes. So when you have halo as in halogen and then alkanes, and again, you have to remember that you're not adding on a halogen, you are substituting one hydrogen for a halogen. Okay, so that's something you have to remember because, you know, carbon can have only 4 bonds. That's it. So alkyl halides are still going to be saturated because we are going to be talking about anything that has all single bonds only. Okay, in this nomenclature, we're not doing nomenclature of alkenes or alkynes yet. So these are just normal alkyl halides. Okay, all saturated, sp3 hybridization, all that good stuff. So just the basic nomenclature. So you know a lot of the basic rules for nomenclature from alkanes. We're going to be using some of the same ones here. Okay. Now, what's going to happen with nomenclature from now onwards is that you're going to have two nomenclatures. One is going to be the general nomenclature, which is the most commonly used names for compounds. And then you'll have the IUPAC nomenclature, which is the standardized nomenclature system. Now, not everything is going to have a general name. Some compounds have general names because they are used so much, but everything is going to have an IUPAC name. I'm going to teach you both, okay? And I can give you both. And when you get in the lab, you may find both names also, okay? So which means you have to know both, okay? All right, let's start then. So let's start with a methane in which you have substituted one hydrogen for one halogen. Okay, so I have tried to take a little bit variety here, but it could be anything. All right, so keep it simple. This is called chloromethane. All right, bromomethane if you have just one bromine, or iodomethane. Now the general name for this one, which I didn't really write here, but you could if you wanted to, that would be methyl chloride, methyl bromide, methyl iodide. Okay, because you have the methyl group there. So let me just write it on the side here, and I'll write it in the PowerPoint later. But because you have the methyl group, so it could be methyl and then whatever it is, okay, whether it is chloride, bromide, or iodide. Okay, that's how it goes as far as the general name is concerned. You can use either. Both are simple enough. Okay. Now for this one, if you have more than one halide in there, then you have to, of course, tell that you have two. So which means the first one here, dichloromethane. Okay, because you have two chlorines in there. The methane tells you still have only one carbon. Okay, dibromomethane. Now, if you had three chlorines, it would be trichloromethane. All right, so, you know, simple enough. Two of these compounds have general names. So the first one, which is dichloromethane, is also called methylene chloride. And the last one here, which is the trichloromethane, is called chloroform. Now, if you had three bromines, it would be called bromoform. If you had three iodine, it'd be called iodoform. All right, so pretty standardized even for general nomenclature. Let me go back here for a second and explain methylene chloride to you, okay? Because methyl chloride you understand, right? Because I just explained to you here. The methyl was the CH3. Methylene is actually the CH2 group, okay? That's what it's called. So let me just remind you again, when we were learning about alkanes, so here is ethane, right? So when you go from ethane to propane, you add a CH2. When you go from propane to butane, you add another CH2. That CH2 is what is called methylene. Okay, so if you had two carbons, it would be called ethylene. So the ene has nothing to do with a double bond. It is to express that it has two bonds missing. That's all. Okay, so if it is 1 CH2, that's methylene, 2 CH2s, ethylene, 3 CH2s would be propylene. Okay, so that's how it goes. So yeah, there is some general nomenclature there. So in the lab, you will encounter both names. Okay, so you kind of have to know both in some ways. All right, so now the last part here is if you have different halogens on there, then you kind of have to name them alphabetically. That's all. Everything else is the same. So here I've taken one carbon. Okay, so you still have a methane because it's a one carbon structure. You still have one hydrogen there. Now you have chlorine, bromine, fluorine. So it's a bromo, chloro, fluoro, methane. I know, fun name, isn't it? Okay, that's how it goes. More nomenclature now. So once you get to 2 carbons, so now this becomes either ethyl chloride or chloroethane. Now, since you only have 2 carbons, whether you have the chlorine here or here, it doesn't matter. So you don't have to number anything yet. Okay. As soon as you have 2 chlorines though, now you have to give location. Okay. Because that other chlorine could be on the other carbon. So 1,1-dichloroethane. Now you can see here, I've given you the general name, ethyl chloride. This one does not have a general name. Okay, the second one does not. Okay, so this was 1,1-dichloroethane. The next one is 1,2-dichloroethane because now the chlorine is on each of the carbons. Okay, now I mean you can write it out as a line structure also. I did not, but if you did, this is what it would look like, right? Here are the 2 carbons and then here are the chlorines. So that's what it would look like. Okay, and then if you have 2 halogens, 2 different ones, just go alphabetically and chronologically, okay? Because there is no preference for one or the other. As far as priority is concerned, priority is given to branching, just like we had with alkyl groups back in alkanes chapter. And so you give priority according to then alphabetical nature, okay? If there is no other priority. Okay, so then if you have longer alkanes, then you have to number, right? So for this one, for the 3 carbon, it's a propane, and now you have to number. So you have to give locant. So that's 2-chloropropane, and then here this one is 2-bromobutane. Give lower numbers as much as possible. This one, the first one, isopropyl chloride, is the general name, because this is the isopropyl group. Remember, in the isopropyl group, the connection is on the second carbon, okay? And then here, this is sec-butyl bromide, because again, sec, because it's a connection on the second carbon, okay? So remember, the groups are, this is a propyl group, okay? So this is where the connection is, and for the sec-butyl, this is where the connection is. What is connected to it is, it depends on what group it is, whether it's chlorine or alcohol or whatever it is. Some more. So if you have more substitutions, then you follow the rules that you know from before. Find the longest chain, then you number from the nearest substituent. Again, branching takes preference, okay? So this is the proper way, not from the right hand side but from the left hand side, okay? So go ahead and number from here, but then again you have to name it alphabetically. All right, so 5-bromo, 2,4-dimethylheptane. Okay, that's how you would do it. So keep it simple, don't make it more complicated. Follow the rules you have learned. Right now there is nothing new, okay? Just keep everything alphabetical and lower numbers, okay? That's all it is. So look through this, let me know if you have any questions. Again, I have the worksheet, so practice on there. Cyclohalides, same thing, no issues. If you have 2 halides on there, you have to number, you have to give the locant. If it was just one, it would be fluoro cyclohexane, but because there are 2, you have to give the location. Similarly here, you have to give the location and also go alphabetical. When you have cyclic compounds, you also have cis and trans possible. So you have to mention that as well if it is shown to you. Now remember, cis and trans is only for when you have hydrogens. If you don't have any hydrogens, like in this case, then you have to follow the R and S system. Okay, and you have to indicate the RNS. So what I've done over here is I've kind of shown that to you with the priorities given over here. So the blue one is for carbon number 1, the red one is for carbon number 2. Okay, so the RNS system follow the same rules that we have, which is that, you know, assign priority according to atomic number, keep the lowest group at the back, and then you see if you go clockwise or anti-clockwise. Or change your view. Okay, so like here in carbon number 1, D is the lowest priority, so keep that at the back. And then look from this side. Okay, look from this side so you can see, you know, that it's going R. Okay, moving along. So moving along, that's all for nomenclature. So now for the classification of halides, and we've done this before with the primary, secondary, and tertiary carbons and hydrogens. So we classify halogens the same way. Okay, so again, look at the connectivity. So if the carbon that is connected to chlorine is connected to only one carbon, that's going to be a primary. If that carbon that's attached to chlorine is connected to 2 carbons, then that's secondary, and then of course that carbon connected to 3 is tertiary. Okay, this is a very important classification for us, so make sure that you learn how to do this, or ask me if you have any questions on it or have any doubts, but otherwise just look at the connectivity. Okay, so I've given you some examples here also for that. Now for the physical properties for alkyl halides. So first of all, boiling points as usual. Boiling points will be higher than alkanes. Okay, we're going to compare to two things generally, alkanes and then water. Okay, a lot of times. So in density, and especially, you know, that with water. But anyhow, so boiling points are comparing it with alkanes. Don't just write higher. Okay, that's what I'm trying to say. You have to say, if it's saying higher, then you have to compare it to something. So we're comparing it with alkanes. So boiling point is going to be higher than alkanes. Why? Because there is now dipole-dipole interactions in there because of the halogens. Okay, so halogens will give it a little bit more polarity. Okay, so you know, with chlorine and fluorine, it's even going to be higher boiling point because bromine is not that polar. Okay, so that's how it goes. So here is the dipole moment given to you, and then we can have you know, higher boiling points. Now if you increase the number of halides, then also the boiling point is going to increase. Okay, so two things in there, number of carbons and then also number of halides, and then type of halide. All of those things you have to account for, okay, when you work on this. Solubility in water is pretty much nil, very less, because you know, you may have light dipole-dipole interaction, but that's not very much. Okay, so generally what happens is that when you take any of, you know, any of the liquids, alkyl halides, which dichloromethane is the most common one that you are going to use. Dichloromethane and chloroform, they're very common as solvents. So when you use them and you dissolve, you know, you don't dissolve them, when you know, work with them in water, the water will smell just a little bit like dichloromethane. So you might think, oh, okay, there has been something organic in there, but otherwise there's no solubility. Okay, and remember, alkyl halides, it's not like they have very high boiling points. Their boiling points are still low, so they will keep evaporating and they will then all vaporize, okay, from the water, so they won't stay that long. Density of alkyl halides is going to be higher than alkanes, right? And sometimes even higher than water, okay? Because the halogens can get really heavy, all right? So higher density, and I will also write here higher than water. So you'll remember, or I will write it for now and I will add it to the PowerPoint later. So, and greater than water also. So what does that mean? What that means is that if you're using a solvent, okay, like I said, dichloromethane, then it's going to be the lower layer, okay, because it's not soluble. So which means that you will see two layers in there, and then the bottom one is going to be the dichloromethane layer, okay, in there. Okay, so there are some physical properties given to you. And finally, odor, okay, and the all halo compounds, they smell. There is some smell to it, but usually it's not bad. Okay, like you can tell that you're smelling something organic, but it's not like I need to get out of here bad. Unless you're allergic to something or really don't like organic odors, it's fine. It works out. You know, it kind of like you have to think about when you bring your dry cleaning home. So you know it's organic, you know it's something is smelling, but it's not really the best smell, but it's not the worst either. Anyway, that kind. Okay, applications, because this is really important thing for us. Okay, we have to learn where all these things are used. Okay, so first of all, as I mentioned, solvents. Dichloromethane and chloroform, very good solvents because they're slightly polar. They dissolve everything from non-polar organic substances to polar organic substances. They have low boiling points, so it's easy to get rid of those solvents. You know, the solvents should have characteristics like they don't react with anything, and then they're also easy to remove when you need them to be removed. So, you know, they make for very, very good solvents. Okay, now, however, of lately, of this year, last year, this year, I think, EPA and all they're asking us to remove dichloromethane and chloroform from, especially dichloromethane, from being used in the labs because they are carcinogens. Okay, so carcinogens meaning something that causes cancer, but it depends how much you're using also. Okay, so if you're using too much of it all the time and you're smelling it a lot, then you know it can be harmful. We don't use enough of it, okay, for us to be that worried about dichloromethane, but still we're going to try and phase it out. And that's what the suggestion is from EPA as well, okay, is to kind of phase it out. Alkyl halides, why are we learning about it also is because you're going to use it in substitution reactions, okay? So which means that they're very good starting materials, reactants, substrates, they're very good for that, okay? So they're very good organic compounds for making other compounds, so very good for that. Chlorofluorocarbons, they're also used as refrigerants, propellants for our aerosols. This is a little bit of an issue also, and so is dry cleaning, okay, as I was mentioning before. Both of these are actually big issues as far as the environment is concerned because both of these compounds, they can stay in the atmosphere for a long time and they go up to the stratosphere where they destroy the ozone layer. We will talk about this a little bit later also in the semester, but these two compounds are really quite destructive, okay, for the environment. They're also they cause global warming and then they also destroy the ozone layer, okay? So this is something we have to watch out for. The CFCs, that's what these are called, short form, right? And so they're not very good, okay, for the environment, but they're very good as refrigerants. So it's like you have to find something to replace these in order to, you know, get a good refrigerant. So it's chemistry, good and bad, both. Anyhow, okay, so then here, dry cleaning, okay, chlorofluorocarbons, they're also very good dry cleaning agents. So when we say dry cleaning, it means what? It means that you're not using water for cleaning, right? Dry meaning no water. So some clothes you've got to dry clean. You can't use water on them because they'll shrink or they, you know, change their nature. So you have to dry clean them. So those dry cleaning agents are alkyl halides. Okay, so now they're changing those also to greener solvents, so you know people don't have to smell these. And by the way, next time you bring your dry cleaning home, hang it out for a while. You know, don't just put it in your homes because our homes are closed environments, and then you will have all of these molecules floating around in your home or in your closet. You know, so just put it out for a while, and then you can put it in your closet. All right, and then we also have alkyl halides as very good starting materials for polymers, okay? And not that plastics are very good or anything, but we use them, right? So we use a lot of these, you know, PVCs like polyvinyl chlorides, terephthalate, and then we have also the polyethylene, all of these things, all the plastics, they're all made from alkyl halides, okay? And varying kinds of alkyl halides. So that's also something we have to watch out for because as durable as they are also not biodegradable, okay? So it's a little bit of a problem. They are fire retardants, again, good and bad, because they put out the fire, bad, now they're in the environment, right? So what do you do? So here, as I've been saying it for all of this. Most of these halogenated compounds are actually toxic in nature. DDT, which we also know as the biggest pesticides, it was kind of banned in US because it has a lot of chlorines in there. Just look up the structure. And just think about something, like if anything is killing any kind of a creature, pesticide, well, it is harmful. Okay, it can harm us also in some ways. I think that's about it for this one. Yeah, that's it. So nomenclature, some physical properties. The applications is just for you to know what everything is. I don't usually ask for those in the exams, but you just kind of for your FYI.